But when they come on array, their must and should be elements are homogeneous only. Whereas here, the elements may be homogeneous or it may be heterogeneous. Whichever student used to talk in between, who is the problematic student, identification of that student, where exactly he was present. That is searching. From which memory location the element is started to store the elements, that position can be called as base address, starting address. Welcome back to One and All. Myself, Vasanta, lecturer in Computer Science, Vidhyaashram, Pre-University College, Temple of Excellence, Mysuru. Today, we are going to start with the second session of Data Structure chapter. Whereas already in the previous class, you have studied regarding data structure. What do you mean by data structure? The classification of data structure, why we need data structure. The data structure is a specialized format for storing, organizing the data in a computer memory. Then, what do you mean by data representation? Then with that, the classification of data structure. Regarding that, you came to know in the previous session. Whereas on today's session, you will come to know regarding non-primitive data structure. What do you mean by array, list? Then operations on linear data structure, as well as how to calculate the length of an array. Then representation of one-dimensional array in memory. With that, the basic operations on one-dimensional array, then algorithm for traversing, especially here for linear array. Regarding that, you will come to know on today's session. Now, what do you mean by this non-linear data structure? Non-linear data structure, here mainly it concentrates on group of elements. It concentrates on group of elements. Non-primitive data structure are more complex data structure. These data structure are derived from primitive data structure. In the previous class, I told you regarding the data structure. On that, we have two types. One is primitive and one more is non-primitive. Whereas primitive concentrates on only one item, whereas non-primitive concentrates on more elements and it is more complex by nature. It stresses on formation of group of homogeneous and heterogeneous data element. In data structure, we told you two types. One is primitive and one more is non-primitive. Whereas non-primitive is derived from primitive only. Whereas here, it concentrates on single element, whereas here, it concentrates on group of elements, where it may be arrays, list, as well as files. These are the classification of non-primitive data structure. Then, what do you mean by array? Why we required array? Array is a collection of homogeneous elements. It is a collection of homogeneous elements. Then, what do you mean by this homogeneous elements? Homogeneous elements means all the elements are same data type, stored under same name, which having some subscript. For example, if I am going to write int a of 10, then it can be called as array, because here we have totally 10 elements, all the 10 elements of integer data type stored by the same name a. That means here I can say that array is a collection of homogeneous elements. And with that, all the elements are of same data type. When you come on types of array, three types: one-dimensional array, two-dimensional array, as well as multi-dimensional array. There are three types under array: one-dimensional array, two-dimensional array, as well as multi-dimensional array. In one-dimensional array, we have only one subscript. For example, float a of 2. It means that here two elements are there. All the two elements are float data type stored by the same name a. But here we have only one subscript, where it may be row format or it may be column format. That is one-dimensional array, it having only one subscript. For example, int a of 2:2. Then it can be called as two-dimensional array because it contains two subscripts. This is the first subscript and this is the second subscript. The first subscript represents the total number of rows here and the second subscript represents the total number of columns on that. For example, here if you have 2:2, then totally we have 2 rows and here 2 columns we have. Then maximum here it can store 4 elements. Two-dimensional array having 2 subscript, one-dimensional array having 1 subscript. And the next one, multi-dimensional array. Then what do you mean by this multi-dimensional array? If you have more than 2 subscript, for example, int a of 2:2:2, then it can be called as multi-dimensional array because it having more than 2 subscript. If you have 2 subscript, then two-dimensional array. More than 2 if you have, then it can be called as multi-dimensional array. Next, when you come on list is arrangement of elements where the elements may be homogeneous or heterogeneous. But when they come on array, there must and should be elements are homogeneous only. Whereas here, the elements may be homogeneous or it may be heterogeneous. Once again, it is classified into 2 types, linear as well as non-linear. When they come on list, there are 2 types. One is linear and one more is non-linear. Whereas linear means all the elements are arranged one after the another without any break. In a continuous memory location, all the elements are arranged. But when they come on non-linear, elements are arranged randomly. Elements are arranged randomly without any continuous memory location. Randomly, if the elements are arranged, then it can be called as non-linear data structure. Next, when we come on linear data structure, it is an arrangement of homogeneous elements. Each element is referred by an index. Exactly on which index, on which position the element is present. Depending upon that, here we are going to access the element. Example, stack, queues as well as linked list. These are the example for linear data structure. But when they come on non-linear data structure is a data structure where data items are arranged hierarchical format. Hierarchical means random format elements are arranged. Then it can be called as non-linear data structure. For non-linear data structure, the data items are not arranged in sequential form. One after the another, elements are not arranged. Whereas in linear, elements are arranged one after the another. In a continuous memory location, all the elements are arranged. But when they come on non-linear, elements are random format, not in sequence format. Example, trees and graphs are the example for non-linear data structure. Next, when they come on operations on linear data structure, it is very, very important because in the exam, you may going to get the question, write the operations of linear data structure. It's a 5 marks question. Then, what are the major operations we can able to perform? The first operation is traversal. What do you mean by traversal or traversing? Visiting each element from the beginning one by one till the end without any deviation, then it can be called as traversing. Consider we have the array elements. Here all the elements are arranged position wise 0, 1, 2, 3, 4. Consider in the classroom we have all the students. Consider this is the first student, second one, third one, fourth one, fifth one. Whereas traversing means visiting each node one by one. First we will access the first student, then second one, then third one, fourth one, fifth one. One by one without any deviation, then it can be called as traversing. Traversing is a process of accessing. Accessing means nothing but taking, processing. Accessing each item exactly once to perform the operation. Exactly once. From the beginning only we have to access the item. Under this, the second operation is insertion. Consider we have the students, list of students. Here, whichever position I want, on that position, I can able to insert the element. That is nothing but insertion. It is a process of adding a new data item. Consider this is the memory location, whereas traversing means visiting each element from the beginning one by one. Whereas insertion means whichever element I want, that element I can able to insert on whichever position I want. That is nothing but insertion. Whereas the next one is deletion. Whereas deletion is a process of deleting unwanted items. Whichever items we don't want, that item we can able to remove from a particular position. It is a process of removing an existing data item from the collection of data items. Here we have several data items. Whichever item we don't want, that item from a particular position, we can able to remove that. Then searching. Searching is a process of finding the location of a data item. Searching is nothing but identifying whichever item I want, exactly on which position that item is present. That is nothing but searching. Searching is a process of finding the location. Not only finding the element, it is a process of finding the location of a data item. The next operation, sorting. Sorting is nothing but it is a process of arranging the elements in some specific order, where it may be in increasing order or it may be in decreasing order. It is a process of arrangement of data item in ascending or descending order. If I want, I can able to arrange the elements in ascending order or descending order. That can be called as sorting. And the next operation is merging. Merging is nothing but it's a process of combining data items of two structures to form a single structure. Whichever elements we want, that item we can combine and we can merge. That is nothing but merging. These are the major 5 operations that we can able to perform on linear data structure. That is, first one, I can able to visit each and every node from the beginning till the end, that is traversing. Not only visiting, if I want, I can say accessing. Then insertion, whichever element we want, that data item we can able to insert. Whichever element we don't want, that we can able to perform deletion. Then searching, whichever data item we want, that item we can able to search their location. Then sorting is nothing but arranging the elements in some specific order, where it may be increasing order or it may be in decreasing order. And the next one is merging. Merging is nothing but combining the data structure to one single data structure. I am going to give one example for this. Consider in a classroom, I want to check each and everybody's notes. Then I will perform traversing. I want to check each and every student's notes from the beginning till the end. Then insertion, whichever student I want, I will call that student and I make the student to sit in a particular position. Insertion. Next one, deletion, whichever student is problematic student in the class, I will send them outside. That is, deletion is possible. Then searching, whichever student used to talk in between, who is the problematic student, identification of that student, where exactly he was present. That is searching. Then sorting. If I want, I can able to arrange the students in some specific order depending upon their names or depending upon their heights or depending upon their marks. That is sorting. Then merging. I can merge girls one group, boys one group. Like that, I can take all the items and whichever item I want, I can able to merge. It's very important question, because usually you will get this type of question for 5 marks. Next, we'll discuss about arrays. Array is a collection of various elements of same data type with the same name is called as array. On this, the array elements are arranged one after the another in adjacent memory location. Consider this is the first memory location, 0. Then adjacent next memory location, 1. Then next 2. Then 3. Then 4. Like this, all the elements are arranged one after the another in adjacent position. Then when we come on one-dimensional array, already I told you, the array which having only one subscript is called as one-dimensional array. It can be denoted with the syntax data type, array name and then size. See, in the example, data type here I given as int, then array name is A, and here the size we are given as 10. That means totally 10 elements, all the 10 elements of type integer stored by the same name A. And the size refers to number of elements in the array subscript, ranges from 0 to n minus 1. Already I told you, in array the first element position is 0, then 1, 2, 3. Then the last position, usually it can be called as n minus 1, because here it starts from 0, that's why the last position is n minus 1. Like this, if the first element position, then the subscript is 0, then second one 1, last one n minus 1. Then if I want to calculate the length of an array, then I have to follow some rules and regulation. That is, array already I told you, it's a collection of homogeneous elements. The array is a list of numbers of data items of same data type in a consecutive memory location. To find the length of an array, there is a formula we have to use. Length equals UB minus LB plus 1. Whereas UB stands for upper bound, whereas LB stands for lower bound. For example, consider this is the array element, position wise 0, 1, 2, 3, 4, 5. In the first position 10, in the second position 20, 30, 40, 50 and then 60. These are the array elements and this is the position. Then how to calculate the length? Length formula equals upper bound minus lower bound plus 1. The upper bound here, what is the upper bound here? 5, the last element position can be called as upper bound. That is here 5 minus lower bound. This represents the starting address represents the lower bound. Upper bound minus lower bound plus 1, then 6. That is the length. Totally 1, 2, 3, 4, 5, 6 elements are present in the given array. How to calculate the length? We have the formula upper bound minus lower bound plus 1. By this formula, we can able to calculate the length of an array. Next, we'll discuss about the representation of one-dimensional array in memory. How elements are arranged in memory. How to identify the location of that element in the memory. Whereas elements of the linear array are stored in consecutive memory location. That means all the elements are arranged one after the another. The address of the first element of the linear array A is given by base A, called as base address. From which memory location the element is started to store the elements, that position can be called as base address, starting address. The address of any element of A can be calculated using the formula location of A of P. That's the formula. Location of A of P. For which position I want to find, write on that position equals base of A plus W of P minus LP. Whereas location of A of P represent for which element I am finding the location. Whereas base A represents the base address, starting address. For example, in this problem, we are consider the base address is 1000. Whichever address you want, starting address, that you can mention. Whereas in this case, I took the base address is 100, where n represents number of words per memory cell. The same thing here I applied. For example, I want to find the third location element. Then location of S of 3. Here, the name we are given as S. S of 3 equals base we are given as totally starting address 1000 plus W represents number of words per cell, that is always 1 only, minus for which position we are finding, that is 3 minus 0, then 1003 is the location of that particular array element. Like this, we can able to identify the memory location of an element in a single dimensional array. Now is it clear for all of you? Next, we will discuss about some basic operations. Basic operations that we can able to perform in one-dimensional array. Whereas in linear data structure, there also the same operations, as well as in one-dimensional array, there also you will get the same question. But the name is there, we used to write in linear data structure, whereas here in one-dimensional array. The basic operations are traversing, as usual, accessing each element from the beginning one by one. Then searching, finding the location of an element. Whichever element I want, I can able to find the location. Traversing is nothing but visiting each node from the beginning one by one. Searching, identifying the location of an element, where exactly the element is present. For example, 0, 1, 2, 3. If I am going to give here this number, this value, then their location is 1. That is searching. Then next one is sorting. Sorting means arranging the elements of the array in some particular order, where it may be in increasing order or it may be in decreasing order. That is nothing but sorting. Arrangement or arranging the elements of an array in some specific order. And the next one is insertion. Insertion is a process of inserting an element into an array. Whichever element I want, that element I can able to insert in the given array. Whereas deletion is nothing but removing an element from the array. Here we have to use the word array. Whereas in linear data structure, there in the list, we are inserting or deleting operations, we used to say. And the next one is merging. Merging is nothing but it is a process of combining one or more arrays to form a single array. These are the operations we can able to perform in one-dimensional array. This is very important question. Usually, you will get this question for 5 marks. Then you have to mention all the operations. Then you have to explain that one by one. Now is it clear for all of you? Next, we will move on traversing. What do you mean by traversing? How to perform traversing? Then how to write the algorithm regarding traversing? That now I am going to explain you. Traversing, already I told you, it is a process of visiting each subscript, visiting each element, each subscript at least once from the beginning to the last element. Consider we have array elements here. First element I will process, visiting, accessing, first element, then second element, then third element. One by one, all the elements we are accessing here. That is nothing but traversing. Usually, for 1 marks, you will get the question, what do you mean by traversing? It is a process of visiting, accessing the elements from the beginning one by one. That is nothing but traversing. For example, consider in the exam, if you get a question, write an algorithm to perform traversing, then first you have to mention what exactly the A represent. A be a linear array with lower bound and upper bound. That is LB as well as UB. If this is the array, here consider the elements 0, 1, 2, 3. This is the position element, for example, A, B, C, D. In the first step, process location equals lower bound to upper bound. Here this 0 represents the lower bound and the last one represents upper bound. Usually this algorithm you will get for 3 marks. Write an algorithm for a linear search or write an algorithm, especially here algorithm for traversing. Here first you have to mention the process. We have to start from lower bound to upper bound. First one, second one, third one, fourth one. Like that you have to mention. For location starts from lower bound to upper bound. Starts from 0 to last one. If you want, you can write lower bound to upper bound or 0 to n minus 1 also you can write. Then process A of location. Whatever in this location we have, on that whichever element we have, process that element. First what we will do, for loop we are given, it will repeat again and again. First time, the location value here it will take 0, then process this element. Then once again it will go back to the loop from this. Here the position now it is increased to 1. Then on this, whatever element is there, that here it will process. Then once again it will go back to the loop. Then third element it will process. Then once again it will go back to the loop, and then fourth element here it will process. Till the last element, till the upper bound, till the position is n minus 1. Till that all the element process one by one. Then later on, end of for loop, finally exit. This 3 line itself carries 3 marks in the annual exam. Write an algorithm to perform traversing. Then you have to mention on this, what do you mean by lower bound? What do you mean by upper bound? What exactly the A represents? A is the array name and lower bound, upper bound. Now is it clear for all of you? Next class, we will explain regarding what do you mean by linear search, binary search, what is the difference between linear search and binary search. With that, we are going to explain regarding binary search algorithm as well as linear search algorithm. Thank you for all of you.